I'm going to ask the question, is there a need or possibility to prioritize where we retrofit buildings for green roofs, or where we place green roofs at all in the city, in terms of recreating or regenerating this landscape that Rune was talking about, recreating the ecosystem? Do we always just put a roof opportunistically where we can, or should we, from the point of view of ecologists and landscape planners and city planners, think about where would the green roof give most back to the city? That's the question of this presentation. And I'm not sure that this is even a useful question, but I'd like to know your opinion. So there are some precedents for thinking about where we should do something, and I'd like to commend Oslo municipality's blue-green factor and the work of the Water and Sewage Agency, Planning and Building Agency, and an Environment Agency in putting together this system, which promotes green and blue structures in new residential building sites. And the question I'd like to ask is, could we think about this promotion and the promotion of ecosystem services, or multifunctionality, as Rune was saying? Could we think about this spatially as well? And could we think about it not only for new residential development, as blue-green factor is pointing at, but also retrofitting not only residential but other types of buildings? This system is already thinking spatially, in the sense that there's an easier minimum requirement for this norm. It's not yet mandatory, but it's a norm. You don't have to have such a high blue-green factor in the city centre as you do in the outer area of Oslo's built zone. So the municipality is already thinking in terms of spatial priority setting in a very simple way, but it is thinking about where to do things. And the proposed green roof strategy focuses on a number of functions or ecosystem services, which would be the functions that provide benefits directly or indirectly to people, on recreation, on dampening, or removing oneself from sources of noise, on the opportunities for learning and knowledge, producing food, increasing biodiversity, controlling stormwater runoff, removing oneself, and to a certain extent reducing air pollution, regulating urban heat island effects, and even absorbing carbon dioxide, as Rune was pointing out, is possible in soil, and also aesthetics. So these are a suite of ecosystem services that have already been pointed out by a number of presentations. Could we think about where in the city we're lacking these, and where we should put these multifunctional green roofs that you've been hearing about today? So we were working in Enable to create a combination of mapping information that one could use to answer this question, at least with the available data and initially. So this is an application that works in Google Earth Engine. It's interactive, and this is a high stakes demo, because I'm not sure if it's going to work. But this would be a tool that could possibly be used by planners to prioritize where to implement green roofs. It's the outcome of the tool is, where is there a lack, økosystemtjenestemangel? Where is the lack higher in relative terms than other parts of the city? And we see this outcome, it's mapped onto existing roof or building structures, and it's showing where, if you combine a number of different ecosystem service layers, it's showing which building roofs are in parts of the city with the least amount of those ecosystem services provided by the urban nature that exists in the city. And you can also you can zoom in on different specific buildings. And the question is, would this kind of tool be useful for planners if you had the idea that you needed to prioritize limited resources in the urban space? So I'm not going to take any more chances with this tool. If anybody's very interested, we're going to have a workshop tomorrow with a smaller group of people who've said they were interested. If you want to come along and be a fly on the wall, then we'll go through this tool in much greater detail. So let me see if I can go back to my presentation. Oops. So now I wanted to explain to you a little bit about the data layers that are behind this tool. So this is the outcome map. We did a number of things with the help of an urban hydrologist at the University of Oslo, Nils Roar Selting. We created a very simple urban hydrological model, which then was applied to every property in Oslo to calculate the relative runoff of those properties given the land cover, so the amount of impermeable soil, tree canopy, grass, different infiltration rates on different layers. So every property and every roof on this property has a score in terms of how much rainfall is being evaporated or infiltrated on that property. And of course, in the middle of the city, there's more water running off. So the idea is then those are the locations where you would have the most in return for having a green roof that handles stormwater. But of course, it depends whether the roof is high up in the watershed or close to the sea. So there's also a factor behind this weighting, how much of the municipal stormwater network is being used by the runoff. When it comes to modeling noise from on rooftop levels, we don't have a model for that, but we're using Oslo municipality's noise modeling at street level. And then what they do is for large buildings, they say that the perceived noise on that rooftop, if it's large enough, is 0. And for smaller buildings and with less stories, there is noise exposure. So with the data available, even if there's a lot of noise in the center of Oslo, large buildings and tall buildings have a noise mitigation factor. So it's kind of counterintuitive. And so you end up with a map like this, which is really one of the most complex of the input data layers. It's not necessarily so that the noisiest part of the cities are the places where green roofs would be least effective, because they don't dampen noise, but they remove you from the source of the noise. And so the greatest impact might be for large, tall buildings in the center of the city with the highest amount of noise. Then the idea is, how much green do you have around you if you're a business or a residential building? How much green do you have on the property, on the ground? If you have a lot, the argument for having a green roof is maybe less. At least that's a hypothesis I'd want to propose to you. And so we've scored every single property in Oslo regarding how much green chlorophyll there is on the property. Also, if there's a lot of green on the street around the property, like the street green view, we've taken Google Street View images and taken some results from Oslo on how much green you can see from street level. The argument is that if there's a lot of tree canopy around the building, then maybe the argument, at least from a public perspective, is not as strong for having a green roof because you have a lot of green on the ground. These are hypotheses and data that we're using in the model. In NINA, we've done pollinator habitat potential modeling for the Oslo area. And we took this data. It looks at the biologists have pronounced on what kind of pollinator resources are in different kinds of vegetation in the city, what kind of insulation is there in edge zones. We've taken this map and then we've said from every single building how much pollinator potential habitat is there within 250 meters, which is the sort of generally assumed flight distance of wild bees. And so every building in the city has then a score about where would it play the biggest role as a stepping stone for wild bee species and pollinators. And that's this map that you see here. Then for urban heat island mitigation, we looked at the warmest temperatures last July in our very hot summer, and we looked at the temperature signal from different kinds of urban structures. And we find, for example, that the difference between tree canopy in Oslo and pure pavement or a building roof without any vegetation was up to 10 degrees difference on one of the warmest days in July last summer. So the urban heat island effect may not be long-lasting in Oslo, but we're moving towards a climate. In 2050, they say that Oslo will look like Bratislava in terms of climate. It'll be 6 degrees warmer in July in 2050 if we can reach the Paris Agreement objectives. So it might not be an issue now, but it might quickly become an issue. So this is what we've put together in this tool. we weigh these things together and we use a combination of weights, which we took from a survey that we did for a number of building owners and green roof implementers that some of you participated in. And then these layers are weighted together with those answers we got from you, and they provide this final map. Of course, what ecosystem services are actually provided in those spaces is up to all the design issues that we've been hearing from colleagues earlier today, and that's not part of the model. What the model is where would a green roof potentially fill the most gap in the city? The question is, are there other things we should be thinking about? So where will green roof services benefit residents? So where are the residents? Okay, we saw from the map that the biggest gap in ecosystem service delivery is within Ring 1 in the core of Oslo. These columns represent the population density in Oslo. And so what we see is the red color represents where there's a greatest lack of ecosystem services, and the height of the column represents where there are most people. So should the municipality be planning or encouraging green roofs where there's both a gap and the most potential beneficiaries? So should we not necessarily encourage or provide incentives as a municipality to office buildings in the very core of Oslo, but we should be focusing on the sort of area between Ring 1 and Ring 2 where we would get most benefit for building green roofs in terms of people that could engage with those roofs. So could we be more tailored in terms of how we zone the city and incentives that we have? We could do this at the city district level, because the city districts have pilot funding where they can, within their city districts, prioritize pilot projects. So you could imagine a city district would look, for example, Sankthanshaugen bydel district would look at only their bydel, and they would say which are the green roofs with the most potential population exposure, where there's the greatest gap. And you see here that it's in the sort of lower area of Sankthanshaugen, but not the closest area to the city. So in summary, where should green roofs planning and policy encourage green roofs? And the question is for debate now. Do you think this tool is too rough, got the wrong criteria? Is it not about spatial planning because it's about local feasibility, as we've been hearing, both social, technical, financial? Is this useful in any way, or how could it be improved? So thank you very much.